Assalamualaikum, good day. My name is Hazarun and I will present on wireless body area networks WBANs and their evolving role as human assistive technology. While often associated with healthcare, our focus today is on life and safety critical applications, how this technology protects first responders and industrial workers in hazardous environments. To understand how these systems work, we must look at the architecture. A standard WBAN has three tiers. Tier 1 is intra-WBAN, where sensors on the body talk to a coordinator. Tier 2 connects that coordinator to external infrastructure like cellular tower. However, the critical innovation for safety application is Tier 3, inter-WBAN, or body-to-body communication. In a disaster where cell towers are down, this allows a peer-to-peer self-organizing network where rescue workers act as a relays for one another, ensuring connectivity remains intact even without infrastructure. Let's apply this to a real-world scenario. Disaster management. Uh, as we can see on the slide, a firefighter is equipped with three types of sensors. Environmental sensors detect toxic gases like CO2, while biosensors monitor vital signs like heart rate and stress, and kinematics track location and posture, specifically detecting man-down events. The goal here is real-time situation awareness. Commanders can see exactly who is in danger and coordinate rescue efforts through low visibility smoke. For the next scenario, this technology is equally vital in industrial sectors like mining or construction. On the left, we see a track warning system. Railway workers are alerted via haptic or audio warnings if a train is approaching, so preventing fatal accidents. On the right, in mining, we can see environmental protection. Sensors monitor for carbon monoxide poisoning or extreme fatigue, creating a digital shield around the worker in harsh environment. To make this reliable, we cannot use standard Wi-Fi. We need the IEEE 802156 standard. This framework is dedicated specifically to the physics of the human body. It offers three physics layer options: narrowband for general low power use, ultra wideband for high performance and human body communications (HPC), which actually use human tissue to transmit signals at 5 until 50 MHz. Security in this scenario is not just about privacy, it is about safety. The standard defines three tiers. Level 0 is unsecure. Level 1 is authenticated, which prevents spoofing, but for critical missions, we need level 2, authenticated and encrypted. So if a hazard zone location is corrupted, it could lead a team into a fire rather than away from it. So data integrity here is fatal if mishandled. Despite the standards, challenges remain. The first is the conflict between energy versus reliability. Batteries require aggressive sleep modes to last, but safety requirements demand always on readiness and instant latency for alarms. Standard protocols like 802.154 struggle here. The solution is Traffic Adaptive Max, which switches modes based on the threat level, working up instantly only when an emergency is detected. The second challenge is mobility. Simulation models are often static, but real bodies run, crawl, and climb. This causes shadowing where body parts block the signal, creating non-line of sight or and OS conditions. So we need dynamic biomechanical models that simulate real human movements to ensure the signal does not drop effectively when a firefighter is crawling on the floor. For the final challenge, we have a coexistence. In a rescue team crowd together, discrete and interference zone where one person's sensors jam another's. Current channel hopping is random and insufficient. The solution is collaborative coexistence where coordinator actively share spectrum resources, coordinating power and timing to prevent collisions. In conclusion, WBANs have evolved from simple patient monitoring to essential mission-critical safety infrastructure. The IEE 802156 standard provides the necessary foundation. The frontier now lies in solving mobility and interference challenges to move from closed personal system to fully collaborative rescue swarms. So I think I will wrap up my presentation here. Thank you for your time. Bye bye.